Okay, and then we'll add so page 106, number 6. The given differential equation is y double prime plus 4y prime plus 13y is equal to cos 3x minus sine 3x. Notice the value of the function f of x. We have the cosine and the sine. These two functions are always permissible in the undetermined coefficient method, since this one will yield only terminating values when we differentiate it for how many times. So the suitable method that we will be going to use is the method of undetermined coefficient. But first, let us resolve the y complementary solution of the differential equation by equating this term here to 0. So we have to 0, and then we use the substitution y is equal to e to the mx. Okay, so when we have y equals e to the mx, we have y prime equal to mx m e to the mx, and then y double prime equals m squared e to the mx. Then then we substitute these expressions here to the original dE, and then solve for the roots of m, and then apply the rules for cases. Okay. Then by substitution we get this is the original differential equation, y double prime plus 4y prime plus 13y equals cos 3x minus sine 3x. Then we substitute the following expressions. We will have m cubed plus 4m squared plus 13 squared, and then plus 13 equals 0. Then solving for the roots, we get m1 equal to minus 2 plus 3i, and then m2 will be equal to minus 2 minus 3i. Now we'll identify that alpha here is equal to y minus 2, and then your beta is equal to 3. Okay. Now using the case 3 rule, case 3 for the undetermined coefficients, we'll have the expression for our y complementary, which is e to the alpha, which is equal to negative 2 minus 2x. Put it this way: y complementary is equal to e minus 2x times c1 sine of beta, which is equal to 3x, plus c2 cosine of 3x. Okay. Now our next task is to find the y particular for the said non-homogeneous differential equation. Then after getting the y particular by the principle of superposition, we'll add this expression and that expression, and the total will be the total solution of the said given differential equation. Okay, so in finding the y particular of the solution, again we have first to find an educated guess about the form of your y particular. Since we have previously f of x equals cos 3x minus sine 3x, okay, and this has the same term inside its inside the function, we can use either a cos 3x plus b sine 3x, and since this has two terms, then we can use 2 here. So this will be the representation of y particular, and solving for the a and the b, which serves our undetermined coefficients, we can also solve the y particular of the said differential equation. Now differentiating y prime will be equal to minus 6 a sine 3x plus 6 b cosine 3x. Okay, and then the double prime, second derivative, will just be equal to minus 18 a cosine of 3x and then minus 18 b sine of 3x. Okay, and then we'll substitute this to the original given and then solve for the a and the b, which are our coefficients. And then we'll have this one. We have our y double prime, which is minus 18 a cosine of 3x minus 18 b sine of 3x. And then our 4 times our y prime p will have this 1 minus 24 a sine 3x plus 24 b cosine 3x, and then for the 13 times the yp term we have 26 a cosine 3x plus 26 sine of 3x. Then add this term here will be for a yp double prime, and this one will be the yp prime, and then this is 4 times, this is 13 times yp. Then after adding and then sorting the following expressions, we get like this: 8a plus 24b times cosine 3x, and then plus 8b minus 24a times sine 3x, and equate that one to our value of the f of x, which was previously written equal to cos 3x minus sine 3x. Okay, and then equate the coefficients, the respective coefficients, and then find the values of a and b. And so by further simplification and then solving for the roots or for the values of a and b, we get 8a plus 24b is equal to 1, and then minus 24a plus 8b is equal to negative 1. Then solving these two systems of linear equations, we'll have the values of a and b, which is a is equal to 1 over 20, and then b equals 1 over 40. Then substitute the values of a and b to the particular solution. Our yp will now be in the form yp is equal to 1 over 10 cos 3x plus 1 over 20 sine 3x. And then by principle of superposition, we'll just add this one to the y complementary to get the total solution of the differential equation. Then now we have the y, the comprehensive solution, c1 e to the minus 2x sine 3x plus c2 e to the minus 2x cos 3x plus the term y complementary, we have 1 over 10 plus 1 over 10 cos sine 3x plus 1 over 20 sine 3x. This will now be the solution of the given differential equation.